The purpose of this technical presentation is to impart the importance of always utilizing ICC profiles. So what are they? Color profiles are an essential part of the graphics industry today. Essentially, a color profile dictates how color inputs will display on a given output. The International Color Consortium, ICC, was created for the purpose of standardizing the multi-platform mediums of color display in a way that it was accessible to everyone. It allowed users and companies alike to be certain that color displays would be consistent across all their devices, assuming the devices were properly calibrated. So how does it work? There are two types of profiles: device color profiles and color space profiles. The device color profile is a registration of the device's behavior for input, output, and display of color-related information. A device is designed with a specific DCP in mind, but like all things, sometimes devices can be prone to defects or slight deviations from expected standards. This means that unless properly calibrated, a monitor can inaccurately display a known color space profile, which more often than not will be unnoticed by the user. Color space profiles are not prone to improperly displaying color because they are international standards for behaviors of color spaces according to their respective gamuts. This means that they are device independent, and therefore if the color displayed is incorrect according to the color space, such as RGB or CMYK, the DCP needs to be calibrated in order for the information to be displayed properly according to the pair's profile connection space. A profile connection space acts as the bridge between the two types of profiles, as well as different profiles within each type. In the context of print, a PCS is what converts the digital information for color into information through ink on a page. Because monitors and any digital output on a screen is created via additive color, subtractive colors used in print need to be properly accounted for in order to best display colors that were once digital. Next is rendering intents. First is perceptual. This intent adjusts the colors in a way that maintains their relationships relative to each other. What this means is that even if a color is in gamut, when moved to a new color space it will adjust accordingly to match the adjustments made to the colors outside of the gamut. Second is relative colorimetric. This rendering intent maintains the accuracy of colors that are within the gamut of the new space, but cuts the ones that don't by replacing them with the closest in-gamut color. Next is saturation. This rendering intent favors maintaining the saturation of the original image at the expense of maintaining the actual hues or luminosity. Most often used for graphics that need to maintain their ability to catch the eye, this intent is not utilized for graphics that need to maintain their ability to accurately display color. Finally, there's absolute colorimetric. This method is a way of proofing content based on the context its output will be on. What this means is that the render will mimic the render given a specific output, such as how it will look on yellow paper versus white paper, or how it will look on a specific type of monitor. Deciding which rendering intent to use is determined by how the content is meant to be displayed, and the best method to determine that is by trial and error and taste on the designer's part. So how does one calibrate their device? Use the devices made for it. When calibrating for digital works, have the monitor in an ideal place. This is a place where there is no glare on the screen, and the overall lighting of the room does not overpower the display. This process then is done with a device called a colorimeter. This is a tool that will be able to measure the color produced by the monitor and characterize the way it displays the displayed profile. Depending on the product, there may also be software associated with the colorimeter that can be used to produce a profile for the computer to utilize. This profile can then be used to tell the computer how it needs to adjust its display colors accordingly. When calibrating for print, use a color hood with a 5000 Kelvin light source along with other lighting conditions such as tungsten, sunlight, cloudy light, or fluorescent lighting to best match the color for the final display output. For printed color, a densitometer is one of several tools that can be used to measure the accuracy of colored ink. This tool measures the density of inks on a page, which means that based on how certain colors should look according to known CMYK values, a printed sheet will have a known density of ink for a given color on a given substrate. From there, it's a process of adjusting the register of inks in order to properly print the colors based on their ink densities. Why is it important? Understanding how the process works leaves the designer with more power to create better pieces of work while removing many of the inconsistencies that could arise without color management.